thank you. I didn't realize I was going to get the whole bio read. That's always a humbling experience. It's good to see everybody. Thank you for joining the panel today. I will go through and let everybody introduce themselves quickly. You've heard from most of the people here, but not everyone. And also we have our celebrity guest star here to my right. Paul, do you want to start?
Sutton, CEO of Software Radio Systems.
Hi, this is Srinivas Sriram from VAV Solutions. I'm the senior manager handling the operations at VALOR Lab.
And the awkward one, I'm Tom Rondeau. In my day job, I am normally the principal director for future generation wireless technologies for the Pentagon. But because it's a holiday and we're still in a shutdown, I am technically on furlough status. So I am not representing the government today. I am simply representing myself. So just a random guy off the street who thinks he knows something about open source software and 5G and future G.
Hi, Ranny, Haiby, CTO of Networking and Edge at the Linux Foundation.
Hi, I'm Jim Shea, CEO at DeepSig, and I'm also on the AI-RAN Alliance, which I know there's a lot of interaction we're going to be talking about here, so I'm glad to be here today.
Hello, I'm Ismael Gomez. I'm CTO of SRS.
All right, well, I'm going to kick it off. I've got a long list of questions, but I also know that everybody here probably has questions for this group as well. So I will start, but we'll make sure to include you all along the way so we can make this interactive. And I want to start because I've been following, the open source space for the radio access networks for some years now, and it has really, really grown in the last 7-8 years per se. To the group, I guess, whoever wants to jump in, Paul might be best suited for this. But has there been a meaningful impact from the fact that we have had open source software stacks for the RAN for some time now? Are they making a meaningful impact on development and/or the commercial market?
Yeah, it's a good question. So I think back to when I was in university and when I was a researcher, and one of the big problems we had was there was no platform that we could use that came anywhere near to commercial implementations. There was this huge gap between the systems that we were trying to demonstrate and the systems that were actually being deployed in the field. And so I think that's the first and biggest difference, is that since that time, we now have multiple open source platforms that are at least implementing the same systems that are being deployed in the real world. So I think that's been a huge benefit for workforce development in general. And we see that inside our own company. I think the other major area that has been impacted, so actually stepping back, you could look at it and you could think no open source RAN software is deployed in large public macro networks, and it's been a failure. But that's not the goal. I think if you look at a lower level within private 5G networks, there's been a huge impact. And from Software Radio Systems perspective alone, the srsRAN project not only is an open source solution, the same code base is deployed in srsRAN Enterprise, which is running in about 50 production networks across Europe and the US. And so I think that the development of that situation where you have essentially an open source software solution being deployed in live 24/7 production networks for private 5G is a huge leap forward. And I think OCUDU will take that forward again.
I don't know, Ismael, I actually probably should have turned to Ismael first.
I would say that another area that it has changed a lot is in innovation. So again, back in our days when we were starting, most of RAN implementations that a student or a researcher or an innovator can use are black boxes. Black boxes that not even you cannot see inside, but often they're very difficult to use. You don't understand how to configure them, or you have to read a manual like this, and you won't understand after reading the manual. And open source obviously opens that box, and you would be amazed the kind of things that we have seen our users doing with it. So often users come to us and say, oh, I've taken your software and I've modified to do this and that. And we are like, wait, what? How have you done that without our help? So just by being able to look at the code, understand it, and know what pieces you can change. I think that this is amazing, and it has been a huge change.
Yeah, I will add to sort of both of those points, having watched graduate student researchers now at different test beds at different universities get their hands on some of this and be able to do this, sort of hands-on experience. Not only are they figuring out things that they can do and creating new features and, and publishing, they're also instantly snapped up by the commercial industry because there's such a demand for people who have a sense of how these things work, which unless you can get into the guts of these things, you're not really going to have a sense. Okay, so next question, and we've sort of talked about all of this over the course of the day, but SRS has been an open source project, or it's been an open source software stack for many years. So what changes when it actually becomes an open source project that is hosted by the Linux Foundation? And Ronnie, you're probably the best one for that.
Yeah, so I tried to convey the message during my presentation, but I'll condense it into a few sentences. So I think it's about how people perceive the project and how confident they feel using it. So as benevolent as SRS has been and as good stewards they've been for the project so far, and we hope they will continue that under the DLF, I think when people see a project that is hosted by a single company, they're not as confident as a project that is neutrally hosted, for example, by the Linux Foundation. So I think we're going to see a major jump in adoption and in the amount of people and organizations that are now feel comfortable to kind of kick the tires or do something more serious with the project now that it's under a neutral governance. And also in terms of contributing back to the project. I think we really try to lower the bar as much as possible for anyone to be able to contribute anything large, small, code, use cases, documentation. And we do have efficient mechanisms to make that work well for any project. And we expect to see that happening with OCUDU as well. So it's both the more adoption because it's now under neutral governance, and also more contribution because it's going to be easier to contribute.
I imagine too, you're also throwing so many more resources, human resources at this once you're building up this community that it just becomes easier and easier to self-perpetuate.
Yeah, I always kind of use this flywheel metaphor where our goal is to create these flywheels where with the aid of these individuals and these processes, things move much faster by themselves, and the communities eventually are kind of self-governed. There's enough people in the community to not just do the work, but to help other people also make efficient contributions.
So I'll switch gears a little bit to the government role in all of this. If you had said to me probably 3 years ago that the government was going to invest in open source software that was going to support some of our wireless networks, I probably would have laughed you out of the room. Given that this is a priority, let's start on how does it change the product roadmap, or how does it change the roadmap for SRS development? And then, Tom, maybe you can jump into with how your priorities can be addressed by making this an open source project.
Sure. So I guess first thinking about the roadmap, within SRS, there's always a balance of resources between building up the open source solution to what is most valuable to the community versus commercial engagement with industry who typically wants to pull us in a different direction around custom solutions and more niche applications. And so this OCUDU project gives us the resources to fully focus on the open source community. And so the technical roadmap has been set by US government and building on the ATIS MVP, which has been defined by North American operators. And so we're really allocating all of these resources to the development of an open source solution that is being demanded by the community at large and ultimately by the operators at a large scale.
So why I think this matters and why the government should step in at a time like this to fund this and to try to provide some kind of global leadership on this. thinking back to the history of the 5G project, if you followed it from kind of 2019, 2020, when they first started putting money towards some of the big tranche experiments, if you remember those terms, a handful of military bases around the country got 5G networks, and they were dedicated to different use cases and experiments. Because we had been convinced by the commercial entities that 5G was ready, and all we had to do was put it out there, and it's going to solve all these cool military use cases for us. We got it out there, we realized it's barely functioning. It doesn't connect to any UEs. No other devices besides a couple of phones could connect to these networks. And we didn't have any ability to actually control those, manipulate those networks ourselves. It was just, we just had to keep going back to the contractors. And even though there was this whole idea, again, this is part of like the public dialogue around the government acquisitions models, is, we have to get rid of the kind of built-in defense industry base. They just control everything. They don't allow innovation to happen. So let's go to commercial industry, because commercial industry is going to work with us. They're going to innovate on top of that faster and faster. And we had the exact same conversations with commercial industry as we had with the defense industry. We need you to fix this problem. Cool, pay us. Which is fair, but it wasn't the same level of let's solve problems together as we have been hoping for. So now, while all this is happening, all these promises have been made about all these cool things that can happen if you have these software-defined 5G-enabled networks for all these different, niche problems, unique things, custom solutions that we in our space have. And then you go and you start looking at all of the potential for innovation, ideas that are out there. I just heard the number. So today, the NSF Viings call that's out there, which is kind of the next generation of their like future G program call, nearing 200 solicitations. There's a lot of appetite for doing things in this space. And when was the last time we saw a major win in this space? And so you start putting those ideas together, and you realize, if we're not breaking this thing open far more than Open RAN ever could, then we're not actually doing the job that we need to do. And so we stepped in there and looked at this and said, no, this is something that has to change. And working with Linux Foundation, who's done this a couple of times before, right? The LF has how many hundreds of projects under you, but there's like two really big ones, right? The Linux kernel and Kubernetes. Everybody knows those two because those were game changers for entire industries. So we looked at the history of how this happens and said, okay, this is that game-changing moment for breaking open telecommunications of innovation space. And just I have a lot more to say on this, but I'll shorten it for this last little bit, which is the future of communications, computation, and AI are so intertwined. They always have been, but they're kind of converging. The math shows us that they converge, except for these really ugly things called antennas. But once you get through there, your ability to compute, where you compute, how you use those resources, how you distribute those resources, changes your way of defining future of AI, the next wave of AI, contextual-based learning, physical realities of AI around you. It's not all going to be based on the cloud inference structure that we have today. It's going to be at the edge. And you have to start merging these together. And this is how computing works. The open source software world has taken over the computing world in general. 80% of all software is based on open source code. So why would we be any different in this space? Because that's how you actually create the basis of innovation. So that's where we came at this from.
I love how you contextualize that, because we have so barely scratched the surface of what you could be doing with wireless networks. I mean, I forget how many developers have been thrown at this from an industrial or commercial standpoint. Once you put all of these things in software and start to add things like the AI capabilities and the edge capabilities, there is just so much opportunity. And another piece to that, which is on the sort of workforce front, I always struggled with, I would have people come to me at different points, in years past saying, well, I don't understand why there's not more of kind of an entrepreneurial community around the telco space. Well, it's because you can't get into it unless you're fully capitalized and part of one of the, the major players that's already there. Okay, speaking of the major players, just because I like to keep the conversation interesting, we've seen Open RAN it is debatable how successful. It has certainly had its successes, but it perhaps has not gone as far as some people would have liked. How do we perhaps counter some of the industry countercurrents that might also upset the vision that we are trying to see with open source? Who wants that one?
I will say just a technical side or my technical thought on why Open RAN is maybe not as successful as we think. And I would say that RAN is extremely difficult. Open RAN is trying to make kind of separating the software from the radio. And separating the software and the radio is something that some of us have been working on this for decades. And it's very difficult. It's not easy. The DU software depends a lot on the radio, and the radio depends a lot on the software. And yeah, I would just say that one of the reasons is that it's not a simple challenge.
And I'll say that Open RAN is a success. It was a necessary transition of the way of thinking about this market. Now, is it a massive commercial success? Is it going to be the brand that everybody looks in the future of, oh, good, I'm connected to an Open RAN base station right now? Probably not, but it was necessary in order to actually help us with the transition into the space that we're now, or the future that we can identify. What was the value proposition of Open RAN? I think that's where we have to start looking at this. What was the true value proposition? Because it didn't really provide a differentiating service. It didn't provide anything really new in the RAN itself. It just offered a different supply chain and construction and challenge to the market. And then we found out, okay, so with that construct, you can make a lot of indoor Open RAN based, small cell kind of Open RAN based, and everybody was kind of commoditizing around the same rough structure. It was just different logos and packaging over top of it. But there wasn't a compelling case to the MNOs, because it was predicated on this idea that Nokia and Ericsson were charging way too much money for their device, and we had to give them a challenge. We had to give them, if nothing else, a stalking horse to make them afraid to drop their prices. But they're up against Huawei, and there's no beating that in the fair marketplace. And Open RAN couldn't change that model. They couldn't drive the prices fast enough down and create competition fast enough to beat the fact that Huawei is just playing on an unfair game. So if you're going to actually transition the telco market into something that is more leaning away from Huawei and away from the Chinese Communist Party's policies on the structure of these networks and the control of these networks, you've got to lean into innovation. And you're not going to do that with just recreating the same black box as a set of the same components that just happen to be open and defined with these interfaces. You got to break it farther open. You got to really experiment with the ecosystem. I look at this from a venture capitalist perspective. So when you look at like the books of VCs, most of us just go to how much money do they have, how much money they spend, how many successes have they had. Well, one of the metrics that you really have to look into is how many deals did they make? Because it's shots on goal, as my friend John Spiritos said at our Isaac Strategy Summit. Shots on goal is what you need in the marketplace. You need to have as many shots on goal because one of those is going to hit. The more you have, the more of them are probably going to hit. When was the last time we had a major shot on goal in the telecommunications market? Because we haven't had that ability to create an industry of innovation, of reducing the barrier to entry to try something new, try many new things. With this integrated systems and communications work that we're talking about, everybody is waiting for the killer app. I don't want to do anything because I need the killer app, because the margins and the profit margins are so small in telco that you can't be wrong. So you got to wait until you know that you're right. But what if we reduce the barrier to entry and allow more people to be wrong and to learn from those mistakes and create the next iteration of that until we actually come across those, maybe the one killer app of Isaac, maybe the dozens, maybe the 5 that are good enough that are going to sustain this world. That's a big part of what we're looking at and why. But to get back to the origin of the question, to get to this point where we have this conversation, Open RAN was a necessary thing. And I think just having had that happen to the telecommunications market, that created the space for this to happen. So from that perspective, it's a huge success, and it's trained a lot of us, and it's opened up a lot of more experience to this that we then need to take into solving all these other problems.
I think that's a great way to put it. And you sort of made the point too, if you're trying to sell into the carriers, you have to give them a revenue stream. And Open RAN was just a new architecture. It wasn't a new way to bring in a particular feature or a particular thing that they could sell and make money off of. Whereas potentially with the open source, you're looking at building new features and functions and things that will actually potentially create whole new markets. One more question on this piece, which is, again, just a little bit of a touchy subject. We've talked about the licensing here, the permissive licensing here, which is fantastic. When we're talking about the larger commercial industry scene, we will also get into some discussion around the patents that already exist. Where does that come into this discussion? How should people feel reassured that they can play in this space and develop in this space without being worried that they're suddenly going to be raked over the patent goals?
Yeah, and that's a key part of the puzzle. So the license that's chosen for OCUDU, the VST 3-clause Open MPI license, is a very, very permissive license. The Open MPI clause effectively says there are patents that are covered by the software. You don't get a license to those patents with this software grant. And so somebody adopting OCUDU and deploying it commercially will need to acquire licenses to standard essential patents. And the 3GPP already has a FRAND system for managing those standard essential patents. I don't have a definitive answer to how a adopter goes and licenses those patents, but this is a recognized problem and this is something we're working on. We're seeing some really interesting things and really interesting organizations start to play a role in this space. Unified Patents are doing something very, very interesting in this space where they're creating patent pools, and they already have a patent pool for the 7.2 RU interface, which allows people to license those under recognized terms. And I'd love to see a similar approach taken for OCUDU, and I think it's something we're really driving towards.
Yeah, that was a great answer, because there shouldn't be a quick and easy answer to that. But the fact that it's part of the discussion at this point is a pretty big deal. Okay, let's switch to kind of less controversial questions. Let's see. Let's talk about the testing community. We're talking about this as being a carrier grade stack. What role does the testing community play? We heard a little bit this morning about the idea of being able to use multiple different sort of testing infrastructures to be able to validate, that people will be able to use sort of automated testing tools and be able to reproduce some of the testing themselves. But Srinivas, give us a little bit of a background on VALOR's role here and what you see as the future of the testing community.
Sure. VALOR is playing a third-party independent evaluator for this OCUDU project. So as many of you know, VALOR is funded by NTIA, PWSCIF, NOPO1. So as part of enabling the ORAN adoption within US, and this is a great example of government agencies coming together to enable the adoption of ORAN. So here two agencies, NTIA and the DOW, using the resources created by the US Parliament to validate any of the ORAN testing developed under OCUDU program.
That's great. Thanks. Does anybody else want to add to that on the side?
I just want to add that on an internal side, testing is super important for us. We do test since day zero, and we are very, very rigorous about our testing. Our levels of quality requirements are very high. And I would say that people would be amazed by the amount of time that we dedicate on testing. I think that it's fair to say that we dedicate similar amount to testing than to development. Testing being interpreting the results or developing new tests. But we often struggle to find a way of testing some advanced features of the spec. And I think that here is where VALOR or the community can help us to define better the requirement and define better how it should be tested to be adequate for carriers for deployment.
Right, because you're getting input from the end users as well in the testing process. Did you wanna add?
No, just I think as the Linux Foundation, we were very good at software development, not so much in radio testing. So I think the OCUDU project will have to rely heavily on those industry resources because it's not something we do or can do or plan to do.
I think Tracy made the point earlier that we also have a supply of ODICs around the country that if we rope into this testing ecosystem will hopefully also play a pretty significant role here in the future. Let's see, I know we kind of had a whole presentation from DeepSig earlier, but I feel like it's worth bringing up again. There was some pretty momentous news last week, 2 weeks ago, NVIDIA and Nokia. How does some of that work and acknowledgement there map to some of the objectives of OCUDU?
Well, I think AI in the RAN has really become mainstream. It's funny, Tim and I, we've been preaching this for 6 years, and last year, just as a vignette, we went to an NVIDIA event, and there was a key person there, was a great advocate for us now, but 6 years ago, he goes, Jim, I think this AI stuff just not going anywhere, And he gets up there and he says, we realize AI is really going to go transform telecommunications. Then the next week I went to a Samsung event and another person who's very prominent now in the AI said the same thing. So I think, this Nokia and the AI RAN computer from NVIDIA are really validating, what AI can do in the RAN. And I think OCUDU is going to be a key technology for really making this widespread. One of the issues we've had is that people have different algorithms. They're all testing in different stacks. It's hard to get A/B comparisons of how well things really work. And I think what we also found is you just can't do the L1. You probably need to be involved in the L2 because, the scheduler has a big effect when you're trying to measure in real life data what's happening. So what we're planning on doing, working with, SRS is to kind of have all the hooks to put AI into the CUDU stack. And then we'll be able to really accelerate development. And, we know that Huawei has probably an unfair economic advantage and things, but, if we can run faster and people understand spectrum is very expensive. And if you can utilize that spectrum better than your competitor, even if you're at a different price point, I think you can start to take market share. And that's what we really hope to happen with OCUDU. I mean, my vision of OCUDU goes way beyond private 5G. I want it to be like Linux, where Linux is everywhere. And I want OCUDU to be everywhere in every network. You'll have companies doing their proprietary derivatives with their own equipment, but still OCUDU as the base technology, I think can be really transformative in the wireless space.
I have to say, I love Isaac, don't get me wrong, but the idea of being able to use AI in the RAN for greater spectral management and adding the spectrum sensing and not just object detection of Isaac, I think is just such a huge untapped opportunity there. I have plenty more questions, but again, you only get this group of people up in front of you every so often. So if anybody from the audience has a question, Leland. Sure.
So, and thank you. This is a great panel here. So you made a great point. It's hard to separate the functions from the RVU. So the senses ain't that the REV path, not necessarily either strategy or but open source CUD kind of leans toward the compute issue, breaking into that virtualized stack and then having the ability to go and manipulate and do what you need to do. But it is not a tracker, that's the actual radio. Effective use of our to need to have access to more radio and then deploying a radio capacity out there. Although I'm not a problem about having radio scope on short, at the same time, do you see the need or the capability of this now driving with the technology to develop more radio architectures that could then turn into a real solution? Compute only goes to some point after that, you have to look at the actual radio and how that's deployed. So
You had to go bring up hardware.
Sorry.
Does somebody want to answer that?
I will say that so again, having an open source DU stack that you can see what it's doing, it's very useful to, as Jim was saying, compare apples with apples. And if we want to compare different RUs, often each would use a very different benchmark. This is something that we see oftentimes that people send us data sheets, but they're using different conditions. So it's very difficult to compare. And even if the configuration is exactly the same, inside there are very subtle differences on how you generate the signal, how you are scheduling the users. If everyone is using a common reference DU that it's also open source and you can see what's doing, I think that it's going to be very useful to compare different RUs and select the best for your use case.
Yeah, to put it another way too, when I look at the value of an open source project is when you find the thing that can be shared across the industry. And that's why we carved out the CU and DU portion of this, because it looked like everybody was just building their own and having to maintain their own beast of a code base as opposed to sharing the burden of that. But wanted to make sure that there were the hooks to allow for business differentiators. So things that can help people build products, sell products, build services, making sure the incentive existed there, not that there's just this one open source code base that takes over everything. And mapping your hardware down to your software down to the hardware is a specialization. Like that is a thing that people could leverage for a business differentiator that allows you to sell a better product or creates competition so that we can then buy better products in the future. So I think what Ismael is saying is exactly we're creating that space with OCUDU, and then it's up to the marketplace to actually figure out how that gets there. You think about like the embedded Linux community. That's a lot of what they're about, is how do we take that Linux kernel and map it effectively down to the smallest swap hardware I can do that solves the market problem that I'm trying to fill here. That's where I see that question going of the RU.
I think we have good success stories and good models for co-creation of hardware and software, especially with OCP, the Open Compute Platform. So we've in the past, or still collaborating with them on stuff around edge computing, for example, where the open source software development is done under the Linux Foundation and the open hardware is done under OCP. I think I don't know if you follow them closely, but they do have an appetite to do RU development, or at least definition of radio abstraction for RUs. So I think we'll see more of that, and especially when something like OCUDU unleashes the progress in the software side, I think they can move forward also with the hardware side.
It was interesting. We heard GTRI earlier also talk about developing a reference platform for the ORU, which I think we've seen attempts at that before, or interest in that before. So I'm also curious to see how that develops. Before we leave the AI track, can we go a little bit more into detail about what the near-term roadmap for AI within OCUDU looks like?
Well, we're working on that right now, but no, actually, so yeah, the preview is we're going to look at some exemplars that we'll provide, and the two that we're looking at is uplink processing, doing a basic push type processing that you'll be able to see, and then also adding hooks in for basic sensing. That's kind of, DeepSig as a company, we have products that do spectrum sensing, and we've seen a lot of application for that interference detection, drone detection, not ISIG, but straight drone detection. So we think that's a market that's very real now, especially in Europe, where suddenly there's a tremendous interest in detecting drones for obvious reasons along border regions. So I think those are going to be the two areas we start with, but we're going to be working together, with Future G, and probably in the January, February timeframe, having our complete roadmap, and you'll see what the timing will be for those introductions. But again, that's DeepSig's business, but we're going to open this up so other people can come put their algorithms in, and we can find the best in class. Is going to make all of us better. And I think it's going to help us get to something that's really economically viable, that's going to set OCUDU apart from what's available in the commercial space. So again, if there are needs, we can drive adoption in a large way, I believe. So that's the hope for the program.
It's a nice segue into talking a little bit about the OCUDU Ecosystem Foundation and how people will potentially participate in like the technical steering committee and developing some of those. I will get to the question in the audience in just a second, but Ronnie, can you talk a little bit about the OCUDU Ecosystem Foundation, why that's forming now? We heard Virginia Tech earlier today talking about getting their paperwork in. We've got a whole bunch of industry partners who are in the process as well. How does that build up now, and what does that look like when we get to the release of the open source project?
Yeah, so as to the why, I think there was a slide I showed during my presentation about the four principles for a successful project, and one of them was a viable commercial ecosystems. I mean, as I said, people don't just do open source for the sake of bettering humanity. They need to be paid by someone who sees a viable business behind it. So this is the role of the ecosystem. The ecosystem is supposed to bring together all the relevant parties and make sure there are multiple paths for creating viable businesses from the OCUDU technical project. As for the technical project, it's sometimes hard to convey the message about what's the difference between a governing board of a fund and a technical steering committee. We try to keep the technical project as meritocratic as possible. So over time, anybody can participate in the technical steering committee or contribute code, whereas the governing board that makes more strategic decisions is usually populated by mostly representatives from the key members, platinum members. Over time, we usually open up more seats for kind of community experts to join that, so it's balanced with the knowledge of the community. But in the beginning, it will mostly be the platinum members represented in that board of directors that will set the strategic direction for the fund and eventually for the technical project.
And what you've kind of alluded there too is this is a way of pooling resources to then be able to direct them to the development projects that are the highest priority.
Yeah, obviously, I forgot to mention that the whole purpose of the fund is to, as I say, pull together the resources required to support the technical project, but also do all the marketing, outreach, education, events, everything that makes a successful open source project successful.
Okay. You want to go to if you want to yell out, I'll repeat your question if that works.
All right, so I have a slightly critical view on OCUDU. So, I mean, if you look at the industry, right, the Mavenir and this wireless, they all died out, right? So I don't think it's gonna work out in the commercial space. Like there are only a handful of vendors and operators, three vendors that own the entire commercial ecosystem. And even if you look at Linux, which is a very successful flat bearer and open source ecosystem, it's not successful in personal company system, right? It's still Windows owns 70% of the market. Where it really became successful is the certs, right? That's where 90% of the operating system are run on Linux and supercomputers and others, right? I think this should find that niche market for OpenPath. Probably Packet 503, probably something else. But if you try to go head and head with big players, I don't think we're going to succeed, right? So I want to hear your thoughts on that, right? Do we have there's an exit plan so that OpenRAN becomes successful in the coming years, right? Or let's say OCUDU, for example. The second question I have for Paul is, we already have open source CU and Deep in terms of OAI or even srsRAN, right? So how is this OCUDU going to change that? So these are my questions.
Okay, so starting with the Open RAN skepticism, and if this doesn't work on a carrier sort of national network deployment, is there a backup plan? What is the alternate success story?
So this goes back to what I said in my last comments there. This is just all about opening up innovation. You've got to create new market spaces for telecommunications to grow. We've got to enable that the seamless connectivity from your edge user device, I shouldn't say edge, from your user device, your end application to the edge, into the network, into the data centers. This is now going to be a seamless compute structure, and we've got to build our communications platforms thinking about that. We've got to create our future AI and algorithm systems and app systems that can take advantage of that. We're not going to do that by having the same old black boxes, right? This is again back to why did Open RAN come about in the first place, was to break those boxes open. Now it's taking it that next level farther, so we reduce the barrier to entry to get into those boxes. That's kind of the trajectory that we have here, and that's how it's gonna change the pace here. One of the things that we've learned watching the PRCs approach to commercial technologies and commercial markets is they love to slow them down. They slow them down, they stop innovation so that they can just keep going at it with, I'm not gonna lie, good business practice, good customer service, and just sheer might and will to take over markets. And unless you're trying to outpace them in a different way, they're gonna win this game. So I fear the stasis that we have in Addis and even Etsy, not going after these bigger opportunities, right? This is why I think the NVIDIA conversation that Jim brought up, taking a different approach to this, thinking about the future of applications, and Mario even said it too, we're just scratching the surface, right? There is so much potential here. There's so many things that we can do by having that AI at the edge in our corner constantly. We've got to tap into that, and right now the status quo is not going to do that, and so we had to step in and build this project, this coalition, in order to try something new that we can see where the end is, not the end, but the next steps are, not just something new for the sake of something new, but thinking through what are the consequences of these different things and how do we get it out there. And again, not here on official capacity, but I would say there are conversations happening right now about how the government can start investing and putting more money into these various parts of the ecosystems in order to create those incentives, offset risk, and enable industry to start testing out more ideas.
All right, I think we should come back to that, but first, the second part of the question was about, we already have OpenCUDU previously, why do we need OCUDU?
Sure. So I will give one quick answer to the first question. I think if you went back 30 years and you looked at Linux and you thought Linux was going to try and compete with the operating systems that were in play at that time, you would never have seen it happen. So this is the start. This isn't going to be a quick and fast journey. This is a long journey, but if in 30 years time we have 30% market share of macro networks, I think that's success. Sorry? Yeah. But I think the other key point that you made was that it wasn't in the mainstream consumer operating system that Linux had its success. It was in a more niche area, well, not niche areas, but in other areas. And I think we're going to see the same here. So not trying to predict the future too much, but some areas where I think OCUDU is going to see massive adoption very quickly. Small cells. So I think small cell manufacturers are going to jump on top of this very, very quickly. NTN. I think satellite operators are crying out for 3GPP compliant NTN RAN stacks that they can deploy in practice. And I see OCUDU scratching an itch for satellite operators, and I see it being adopted there very, very quickly. Okay, so then moving on to the second question as to what changes with OCUDU. You're correct in saying that there were open source CUDUs before OCUDU. What I would say is that there was never a production grade deployable permissively licensed CUDU, and that's really the biggest difference here. Is the two changes that we hinted at before, the change of the license from srsRAN being AGPL to BSD based, that removes a huge barrier for commercial adoption. And the transition from a single company project to a neutrally governed project removes a second major barrier. But then the second key part of the equation is the production grade deployability. And so the huge emphasis within the OCUDU program on third-party test and validation is critical to that. And so it's not a project to develop open source software and put it out into the world. It's a entire ecosystem around that. It's building the Linux Foundation Ecosystem Fund. It's contracting and partnering with third-party test and validation partners who are really going to put this software through its paces and test it in all of the niche cases and the corner cases. And I think that's what's really going to make the difference.
I thought you already had underpipe, but isn't that production?
It is, and that's deployed in production. The key difference is that first, people have to pay for it. And second, they have to go through a license negotiation process with SRS to get to that point. And so certainly that is deployed in production. It's used in a large number of private 5G networks, 24/7, large numbers of users. But that key change of making it permissive and making it freely available and having it neutrally governed, I think is going to make the big difference.
And one real thing on that, right? Yes, enterprise grade, but the call for OCUDU was carrier grade. And even if it turns out to be the same code, maybe they've written their code that it actually is survivable in that carrier grade of scale and reliability. It still has to be proven out. And no one's going to believe that until it's proven in scale deployment. So that's one of the key challenges here to make it more robust in that way.
So on that line, by the way, this is each to take a important discussion. On that line, how are you gonna be able to say that what you have is a carrier grade if the carriers don't deploy? By the way, you were mentioning small cells. The small cells are also part of the carrier's network. So if they don't, or adopt this, then you won't be able to test it.
So the question was if the carriers don't adopt, how do you prove this is carrier grade? Chicken and egg.
Sure. So I think the talking about small cells, I do see carriers adopting small cells that are running OCUDU. Yeah, I think that's going to happen very, very quickly.
And yeah, talking about carrier grade testing, I guess that it's also something that that side can reply. It's all about testing with the same level of demand and detail that we test or carriers test their products before deployment. Carriers don't deploy their products and wait to see what happens. They have tested before and tested with VR equipment, with Keysight equipment, and it's a matter of doing the exact same level of testing that they do.
Yeah, but obviously, you have to put it in the level, but whenever I'm going to give the lab issue. However, I would sleep back there, but
yeah. It's a great question, and it is a big challenge. The conversations that I've had with the carriers are they're rightfully skeptical, but they're excited. So they're going to follow along. They want something like this to exist, but they're going to maintain skepticism until we can mature enough, get it to them, have them test it out in their own time and their own system. So. And there's also, I will say, there's a handful of international mobile networks that I've communicated with that are a lot more aggressive in adopting stuff. So that we might have some earlier opportunities and stuff like that, but outside of the United States.
Yeah. I just feel I need to clarify something about carrier gradeness. And you use the example of the Linux kernel. So here's a news flash. Linux kernel is not enterprise grade. SUSE Linux, Red Hat Linux are enterprise grade. So open source projects are potentially carrier grade or enterprise grade, but it's up to the vendor who sells the distribution to prove that is carrier grade. Okay, so the code that sits on the repository is never carrier grade or non-carrier grade. Just a clarification.
All right, before moderator's prerogative here, real quick, because Paul, you mentioned the NTN piece or the satellite piece, which it was alluded to in a roadmap earlier, but can you talk just briefly more about that, about how this plays into the burgeoning satellite market? Because we're seeing that cause some serious ripples.
Yeah, absolutely. So there was I think Jeff listed the DoD requested features that were part of OCUDU, and of those features, a number of them were selected for implementation, and NTN is the biggest of those. And so we have a clear roadmap through end of 2016, end of 2017. We have 2 clear milestones for NTN support, and so within SRS, we're already seeing significant adoption of srsRAN for NTN, and I expect to see that continue with OCUDU.
I can't wait to see where that goes. Okay, I saw some questions over here first, and I am going to take the mic.
Thank you so much. My name is Shea. I'm from Braxton. So I had partially I agree with him, but in the core project, we are working on the OCUDU and we are working with the different aspects, engineers and the students. So I have actually seen the open source. I have seen the benefits of that, students, how they are utilizing that. So one similar questions I have here. I don't see the reports. I feel that it's still best projects. They have they have some answers. Maybe due to the business, or maybe due to they want to see that the technologies are mature enough. So what is your thoughts about that? Related to that question, it's for example, if you see the about that it will not go, but in the industry, maybe it will only be focused on the institute like for the emissions. So would you guys like to continue? Do you say it is beneficial, as I said, like engineering for the voice of our last provide that imports that all the students are like fishing using this open source technology. So what is your long-term goal if this doesn't integrate with the commercial hardware?
I mean, I think that a few people have already said that this is not going to be a short journey. And I understand that at the beginning there will be a lot of skepticism. And I think that eventually I firmly believe that it will be adopted by carriers. Maybe it takes a while to be adopted in big networks like the ones in the US, but there are many other smaller networks like in NTN, like in other countries, where we can demonstrate that it can operate and it can be carrier grade. And I also liked a lot his point about you cannot see OCUDU as an end product, or not necessarily. OCUDU is, I believe, a platform on which other vendors are going to build products that will suit the needs of Verizon. So think even Nokia, Ericsson, that's what I would like to see, building their next RAN software on top of OCUDU or reusing some of the parts of it. So that's I guess that the end goal here from my point of view.
As a carrier, I see that anything which is for the carrier benefits, no matter what the OEM shortly have think quick, so people adopt that technology, right? That it's happened as it did. Like in the architecture wise, plus we are saving some money, so carrier will pay top. Yeah, friend very low here, but also they are not a friend and they will not think about that. Okay, then.
Sorry, that was some added commentary about the carrier role versus the OEM role. We take somebody from over here. There were a couple hands raised.
I can talk about it. Okay.
Also for the recording, so.
You're great. I feel like Shea creates really how to do blind bucket as a spectrum. Do you feel like unlicensed spectrum going forward is really a HCA? Like, where you think that that's going to take the technology forward or a option there? Really like, I really find things.
Yeah, good question. I think spectrum is always a barrier, and I think there has been there were huge strides made in unlicensed and lightly licensed spectrum globally, here in the US with CBRS, across the UK, across Germany with other light licensing schemes. There is a feeling that that's a little bit under threat at the moment. But I think that's where you really start to see the initial innovation. And so certainly for projects like OCUDU, getting deployments where or removing spectrum as a barrier to deployment of OCUDU, I think is critical. So I think initiatives like CBRS, like light licensing in the UK and Germany, I think that's where we're going to see some of the really interesting initial deployments. Yeah, so that's a really good point.
Yeah, one thing I was observed on that is the unlicensed cellular spectrum hasn't really taken off. There hasn't been a lot of activity there. I think a lot of that's probably due to the cost of infrastructure and deployment and maintenance and upkeep of these networks. Whereas you see so much of the innovation coming out of Wi-Fi, right? There's so many new things every day in the markets of Wi-Fi because of exactly that problem. Now, CBRS. Nobody laughed. That's good. Certain communities, you say CBRS, you get a lot of people scoffing at CBRS as a failure. I think one of the challenges is when we started digging into various people who are using CBRS, as if you all remember the one big beautiful bill, the reconciliation bill that went on, there was this whole spectrum argument happening, and with my professional hat on, I was actually a huge part of those conversations. So I saw intimately what the conversations were around this were, and they were saying like with the Wi-Fi, the unlicensed spectrum was so key to the future of small business innovations and where investors are going to put their money into the future. We've got to go after protecting that. Versus what's happening in the cellular world, which was so you had the Wi-Fi Alliance and you had like CTIA on two sides arguing their industries were going to benefit from different parts of how we allocate spectrum, and everybody was attacking CBRS because CBRS, as I said, when we started looking into the marketplace, there's actually a ton of use of CBRS out there. Any one of them is fairly small, but you start to think about collecting them all together, and it starts to look fairly compelling that there's a success case for CBRS out there, but nobody's brought that together. There's no alliance really that's really presenting that argument, at least within Capitol Hill, to make that case. So yeah, I think having thoughts about again, back to my phrases, lowering the barrier to entry, creating more shots on goal. Spectrum is a huge part of that, and maybe there's some future here. I think what we're talking about is independent of that because we can look at these different markets for what they are today. But I think it's a good point to bring up is that there's some, if you start to look at all these different sectors here, there's some potential for innovation to happen and new ideas to come out of it. But the spectrum deal is, I ran into a guy in the Pentagon the other day who is not from the spectrum world, but was tapped to ask me a question about spectrum, and I said, "Oh, I'm so sorry for you. Now you're in the spectrum fights. You're never getting out. You're stuck here for life. This is one of the hardest ones we ever do and deal with in this world."
So if you're not part of the National Spectrum Consortium, you should be, because we have these conversations regularly across all the defense industrial base, as well as all sides of the commercial industry and the government as well. So somebody keep me honest on time, Laura? One more? Okay. I think, yep.
Well, I'll make it last then. So, I mean, I guess there I have some good news, some bad news. At least I'm the some bad news, really. The good news is that, the whole lowering marriage, entry, the innovation that's being derived from OCUDU, that's all interesting. Partly because hopefully this next year will be my past year. I've been around since 2D, and I don't really want to participate further down the page. So that's all great, because I'm seeing a lot of people behind me, young people who are entering age. So I think that's all great. But the problem that I realize, though, is that even with the AI ring, because I follow this, I don't necessarily see a sex utilization issue, at least in the U.S., right? I don't see a spectrum issue in the U.S. Maybe in other countries it's an issue. Here in the U.S., or at least North America, it's really more about connectivity. I mean, if you tell me that I can have connectivity wherever I take my device, I will be very, very happy. The problem is not having access to more bandwidth or having better spectrum efficiency for my device. It's just a lot of times just CD connectivity. So my question really is, how are we handling that challenge, right? What is OCUDU going to do to really help close that gap as far as connectivity is concerned?
All right, again, Tom, personal opinion here. We do have a spectrum problem in the United States. The commercial sector is constantly asking for more spectrum. They're demanding it to get back to the reconciliation bill. Because of that, it started off with 600 megahertz of DoD spectrum was going to get sold off to commercial, in mid-band spectrum to commercial utilization. By the time we were done, we had actually protected certain specific bands that would be very, very hard to move out of from the DoD that were up for potential auction. We got those protected, but the compromise was it was now 800 megahertz of mid-band spectrum for across all federal users. So it was a little bit of this give and take here, but it showed you, and like these are multiple high-level senators that are fighting about this perspective because of this demand for spectrum. But why is the demand for spectrum? From a technical perspective, but also really a business perspective. And so what you realize when you look into this is that spectrum is an asset and it's non-depreciating. So if you pay $10 billion for that 50 megahertz of spectrum, you always get to leverage that as a $10 billion asset, no matter what happens. What does the network equipment that you install in the field depreciate at? Pretty fast. It's more effective to buy spectrum than it is to buy networks. That's how we set this ourselves up in this country. So that's why we have a coverage problem. On average, we have a base station about every 600 meters. The rest of the world between 250 and 300 meters. When I was doing some work in Serbia, they still haven't done their spectrum auction for 5G. It's coming up soon. The book has finally been released. The rules have been released, so they'll be selling off their spectrum soon. When I asked them about this, what do they think that they're going to net from the spectrum auction of like 100 megahertz? 100 megahertz in our world, it was what, 80, 90 billion dollars. They were expecting about $110 million in revenue generated from that auction. Now, granted, they're a 5.5 million people country, but if you still do it per capita, it's still 10 times lower spectrum per person in Serbia than it is here, because President Vučić knows that he wants to talk to his people. He wants them to have access to his network whenever he wants to say anything to make sure that he stays in power. That's how the rest of the world looks at this. So yes, we have a very different perspective on how we run our businesses here and how we run our spectrum here. That plays a role into everything that we talk about. So till we fix that, then we're not going to get the capacity or the coverage that you talk about.
That's a heavy one to end on. Can we do a super quick lightning round of let's say 3 years at the end of this, we are massively successful. What does it look like what does OCUDU and the ecosystem look like in 3 years?
Diverse and vibrant. And so a huge range of different players using it for a huge range of different applications.
I would be like to see OCUDU operated by multi-vendor, vendor neutral production across the industry.
That 6G, OCUDU, and AI are said interchangeably.
I think if OCUDU becomes the synonym of OpenCUDU, then we've succeeded in our mission.
One of the major OEMs realizes they got to run faster, and OCUDU is the way to do it. They have their proprietary version, but it's based on OCUDU, which is opening up a huge developer community so they can accelerate faster than their competitors.
On 3 years, I want to see Verizon deploying the CUDU and coming to us with bugs and with issues and demonstrate that we can do it.
Well, that was a great way to end it. Please give a big round of applause to Haiby now.